Okay, to calculate the frequency, okay, so the generated voltage. Okay, so you move this line here to approximately the end of the waveform, and okay, so after which obtain the difference between the uh, time. Okay, so for this point and this point, that's 553. Okay, so that's 553 microsecond. Okay, so that's take the 553 microsecond. Okay, so we can now close this graph. Okay, so from the oscilloscope, and we go to the so for the frequency, so you can take, okay, so the inverse of the period. So remember that the okay, so the frequency, so that's equivalent to 1 over the period. Okay, so dividing the okay period, so will result to the frequency in hertz. It's 1808. Okay, so next is to change the value of the field resistance to 70%, as shown in the table. Okay, so you notice that the values, no, for the speed and the output voltage changes. Okay, so during the changing of the field resistance value, so you have to wait. Okay, so until the values for the speed and the terminal voltage will somehow be stable. Okay, so that will take some time, okay, for the values to become stable. So for the speed, it stabilized at 26.2 kilovolts. Again, you just need to change the unit into RPM. For the terminal voltage, so we'll wait until the value will be stable. Okay, so that's okay, so it still changes. Okay, so you notice that the okay, the value of the speed drops to 26.1 or 26,100 rpm. Okay, so we'll just wait until um, all these values are in stable, or we'll wait, no, until these values will be stable. Okay, so it looks like uh, the values now are stable, so you can now record. Okay, so for the speed, that's 26,100 rpm. The line to line voltage, okay, so at the alternator terminal is 2.68 kilovolts. Okay, so the line to line voltage is around 2680 volts. The speed is 26,100 rpm. So for the frequency, Okay, so we open the oscilloscope. Okay, so again you start with the beginning of the cycle. Okay, and then uh, the second line will be at the approximate uh, end of the cycle. So that's around 572 microsecond. Okay, so 572 microsecond. Okay, so you divide 1 over 572 microsecond, and it will give you the uh, corresponding frequency. Okay, so you continue gathering the data for 60% up to 10%. Okay, so as I've mentioned, you need to wait, okay, for the values to settle down into the fixed one. Okay, so and after which you will be tasked to graph. Okay, so the following parameters: the line voltage versus the speed. Okay, so the frequency. Okay, so versus the speed. Okay, so of the alternator, and then do some sample calculations, and then do the interpretation of the data. Okay, so you refer this part to the table in table 1.1, and for the conclusion you refer this one to the objective of the experiment. Okay, so that's for experiment number 1.